Hey, Get Math students, this will be a video for data probability and stats basics, notes 120 to 123. So if you don't have your packet, hit pause, go grab your packet. And this video hopefully will be a little quicker than the last two. The notes so far necessarily haven't been hard, but they've just been a little long. Some of these should go a little faster. So we'll be on this page that you see now in your packet. So make sure you get to this page. We're going to kind of skip around a bit. I'm going to do them in a certain order, do all the certain types together. So we're going to look at circle graphs first. We're going to look at stem and leaf plots. And then I'm going to skip to misleading graphs and finish with box and whisker plots. So we're going to go first to problem number 6. And there's going to be quite a bit of skipping around here, but I want to get them all done in the correct order and group them all together. So first of all, the circle graph, not always, but generally is presented to you with percents. So we're just going to look at how to find those percents in this problem, and then this problem is asking for which, given the data, which circle graph would be used. So it says they have a monthly budget. It says $140 is spent on food, $210 is spent on housing, and $350 is spent on other items. Represent these data with a circle graph. So first thing for this type of problem, if they don't give you the total amount of money spent, you're going to find the total of whatever you're dealing with. In this case, it's money. Okay, so all you're going to do for that is take all the categories. So this one, there's only 3. Okay, there's 140 on food, 210 on housing, 350 on other. You add those up, you get $700. Okay, then after that, you're going to find what percent are each of these items. So we're going to look at food, we're going to look at housing, and we're going to look at other. So remember, finding a percent, that's kind of like a test score. So food, you're using 140 out of your $700. Okay, now this was all stuff we did in previous sessions, but just talk through it as a review. I'm not going to write out every little note here, but you divide to start out with. That's going to give you the percentage as a decimal. So it comes out to be 0.2. Now you need to convert that to a percent. Okay, percents are 2 spaces bigger than the decimal. So we have to go 1, 2. There's an open spot, so I'd put a 0. So that's 20% for food. Okay, now at this point, if you look at your multiple choice, if you feel you really did that correctly, you could eliminate A and C, because if food's 20%, this says 15, this says 10. Now we can't necessarily just circle B because there's also this none of these choice. So it could end up being none of these. So let's look at the housing. Housing is 210 right up here. Okay, out of the 700 total that we found. We divide that, so hit 210 divided by 700, you get 0.3. Again, we got to go 1, 2. That's 30%. Okay, so far B is working. We got 20% for food, 30% for housing. We're going to find the other. If it ends up being 50%, this is our answer. Anything else, it's going to be letter D. Okay, now it should be 50% because everything together should add up to be 100%. So 20 and 30 is 50. We should get another 50, but let's check. 350 out of the 700 is for other. You divide, you get 0.5, 1, 2, 50%. And there's our answer. Okay. All right, I gotta find what problem. If you finish copying that, I gotta find what problem we're doing next. Go to number 12. Now, at any time, if I go too fast, hit pause, copy things down. If you can't read what I write, because I don't have the best handwriting and it's hard with this pad, rewind it, listen to it again. So this one's not a lot of math to actually do, maybe just a little bit. So the circle graph below represents a student's spending. Estimate the percent of the budget that was spent on food. Okay, so you look at food here. Now these are all pretty similar, so it's going to be hard. There's going to be a little math we're going to do here. It's kind of hard to look. I would say for sure it's not 25%. Okay, that one, it looks bigger than 25. 25% is 1/4, and it's over 1/4. Okay, but I don't want you to just totally guess. There's a better way we can do this. Take one of these sections that you kind of know for sure. If we look at this looks like 1/4 or 25%. Now we're not looking for music, but by knowing that the whole circle is 100%, if this is 25%, that leaves 75%. Okay, between two sections. Now, if we thought those are the exact same, I'm not saying they are, but if we thought, we would divide by 2, and that would give us 37.5%. Well, that's not a choice. So let's look a little bit closer at these and see if we can figure out. It's kind of hard just looking at this to see which one you might think is bigger than the other one. So what I'm going to do is I'm going to draw in a little imaginary line straight up here. Okay, this would be 25%. Also, if I drew a little imaginary line this way, this would be 25%. Now, if I look, this little section looks bigger than this section. This section here, okay, looks bigger than this little section. So if this is 25% and this is 25% and this is bigger than this, the food would be just a little bit bigger than the other. So if they were equal, we said it would be 37.5. Oops. Okay, but it says food is just a little bit bigger, so I'm going to go just a little bit bigger than 37.5, and I'm going to say 40. Okay, which would mean this one would be 35, and that seems like it would make sense. 45 isn't a bad guess, but I think this looks bigger than 30. Okay, so again, it's an estimate one. Even though estimating, you're not going to get it exact, there is an answer that it will be better than the other answers. Okay, I think we got one more circle graph, or maybe two more. All right, we're going to go to number 13, just on the next page. Okay, it says grade 7 students were surveyed to determine how many hours a day they spent on various activities. The results are shown in the circle graph below. About how much time altogether was spent on socializing and eating. Okay, so we're going to look at, we got to find 2 different activities. Okay, socializing and eating, and we got to find out how many hours they spent doing those 2 and then add them together. Okay, so now the first thing we need to know, if we have these percents, we got to know what's the total. You know, like the other problem we did, there was $700 total. Okay, and it doesn't tell us here, but it says this has to deal with hours a day. So a day has 24 hours. Okay, So these percentages, if we have to find the hours they do them, we have to do that per day. So this would be 13% of 24. Now going back to last session, to figure this out, we take the percent as a decimal times the whole or total, which is 24. So move this 2 to the left, that's 0.13, okay, times 24. You're going to get a decimal 3.12. So a little over 3 hours socializing. Eating, 8%. So we got to find 8% of 24 hours, because the whole day is 24 hours. Move this 2 to the left. So it's 0.08, because if you move it 2, 1, 2, open spot goes to 0, times 24. Gives you 1.92. Now there's some other problems on here where you would just do, they would just ask for one of these. This problem is just one step more because they asked for 2 of them together. So some of the other problems in here will be a step easier than this. So now we just add these 2 together and we get 5.04. And the question says about. Okay, so it's going to be, the closest one is 5. Okay, and I think we have one more circle graph problem we're going to look at. Let's see. Maybe not. I took one off. Yeah, actually, I don't think we do. So that's good. We go back here. So this one would be just like the one we just did. You're finding 25% of the total. And we did that one. Same here, a percent of the total. So doing what we just did, but just once. Okay. Oh, there is one more. Let's see where it was. Number 19. I almost missed it. Almost missed it. All right. So flip and find problem number 19. Okay, I missed it because there's no actual circles given here, but it involves a circle graph. It says, survey about the art program at school found 200 students wanted an after-school art program, 250 wanted art classes during the day, and 50 students thought the school should have no art program. If a circle graph were made of this data, what would the measure of the central angle be for the in-school group? So first thing, there's nothing that says in school. So we need to know that this is the same as in school means during the day. Okay. Now the steps for this. Find a total, because it doesn't give us a total. Because to figure out a circle graph, you have to figure percentages. To do that, we find the total, and in this case, it's students. Like the other problem was money. Find total students. So we have 3 categories. After school, there was 200. During school, it was 250. Now, don't just see a 250 there and think, oh, because there was 250 that said they wanted during the day. Well, the answer is 250 degrees. That's not true. Okay. And then 50. So we add that together, and that's 500 students. Okay. The next thing we're going to do, the main thing we're looking for here is the in school or during the day. So we're going to find the percent of the in school group. Okay, so finding the percent, here's the total. 250 said in school. So just like a test score, it's 250 out of 500. Okay, that gives you 0.5, 1, 2. That's 50%. Now again, that's not the answer. That's the percentage. We got to figure out what's the angle. Now you might be able to just do this right now because it's 50%, but I'm going to show you just in case that ends up being different. Now, what we need to do is find 50% of the angles in a circle, which is 360 degrees. Now this right here, this will be the same for every problem that you would get like this. The percent could be different depending on how many, like if it was asking for after school for this one, that'd be 200 out of 500, you get a percent, and then you take that percent of 360. So change 50% to a decimal, 0.50 of 360. Okay, that gives you 180 degrees, and that's your answer. Okay, if it said, you know, if it gave us a different, like 50 students, if we did 50 divided by 500, that would give us 0.1 or 10%. Well, 0.1 times 360 would be 36 degrees. So if it asked for the no art program, that would be 36-degree measure in a circle. So meaning if you drew your circle, 50% is easy. It's just a straight line, but that's actually a 180-degree angle. If we had to do the one I just talked about, it'd be you go here and you measure with a protractor 36 degrees. That would be the no art program. Okay, but it didn't ask you to make it, but I'm just showing you as an example there. All right, so that's all the circle. Next ones, we're going to do stem and leaf plots. Okay, these ones should go a little quicker. Okay. The misleading ones will go even faster, and the box whisker takes a little bit. So we're going to go to problem number 11. Stem and leaf plot. What this means is a stem and leaf plot means it's just a quicker way to organize data so you don't have to write out as much stuff. These, sometimes you'll see a key over here, meaning this would equal the number 14. This number on this side of the line is your tens place or your first number. Then anything over here would be your second number. So here, we'll write these out and then it's just asked what data are represented. So basically what they're saving time is not writing the first number over and over and over. So this would be represented a 5 and then a 3 is 53. 5 then a 4 is 54. A 5 then a 5 is 55. 6 and a 0 is 60. 6 and a 1 is 61. 6 and a 4 is 64. Now 7, if there's nothing here, don't say 70. There's just no 70s. There's nothing here. Then it goes 83. 8 and a 4 is 84. 8 and a 6 is 86. I'll just make sure there's 2 here that are, pretty similar that start with a 53 and end in an 86. So these 2 are out. And then just make sure you got every number and that you got the right amount of numbers. There's 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, and they all match up. That's your answer. Okay. Just a couple more of these, and we'll move on from these. We're going to go to number 8. So this one tells you to find, they give you a stem and leaf plot, and it says find median, mode, and range. So not mean. If you read that wrong and you start finding the mean, it's going to take you longer. And I'm going to do these in reverse order because some of them are pretty easy. So range means the high minus the low. Okay, so the highest number here, we're in the 50s. The highest 50 is 57. The lowest is in the 20s, and the lowest one is a 20. So that gives us 37 as our range. So we can cross out B and C. So that is 57 as the range. Next one I'm going to look at is mode, because the mode is the one that occurs most often. Okay, so in the 50s we have 53, 53, so that's twice. 55, 55, there's 2 there. But if we look up here, we have a 20, a 20, and a 20. So the mode is 20. So this is our range. So our mode. So out of the 2 left, this has a mode of 0. This has a mode of 20. So this is out. So our answer should be D. Now we can double check here, make sure our median is correct. The median, there's a couple of different ways you can do this. You can count how many you have, or you can bounce back and forth between the low and the high and cross them off. Like, so I could go high and a low and wait till you meet the medium in the middle. So 20 there. And 32, so cross off 53, there, there. And right there is the one that's left, and that's a 4, 5, so 45. The other way you could do that is look at, and that matches our answer, is you can count them. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 items here. So the middle, you'd have 7 below it and 7 above it. So we go 1, 2, 3, 4, 5, 6, 7, counting from the top down. 1, 2, 3, 4, 5, 6, 7. There's our middle number. Okay. All right. I think that's all I'm doing for stem and leaf plots. There's a couple other problems with stem and leaf plots. Maybe I'll give you a hint. Like if we look at number 9, I'm not going to do this one, but it just says which frequency distribution shows the correct. So you're saying which one of these matches these. Well, you're just looking at how many are in each interval. Well, if you look 50s, there's 52, 54, 57, 58. So meaning there's 1, 2, 3, 4 50s. So if we look at our choices, that has 4. This one says 5, so B's out. This one says 3, so that's out. This one has 4. So then you just do that for the 60s, 70s, and 80s and see what answer is correct, A or D. So I'll leave that one for you. We'll take the time on that. All right, I'm going to skip to misleading graphs now, and we're going to finish with box and whisker plots. So these should go a little faster. I'm going to go to problem number 1. Misleading graphs just means there's different ways that you can set up a graph, and it's not necessarily wrong, but it just makes it look different to make it show what you want it to show. So it says both graphs represent the number of new clients signed up each month at Superior Realty. Which statement is true? Okay, the 2 graphs use different data. Well, if you look, April's at 70, April's at 70, March is at 60, March is at 60. February is just a little under 70. February is just a little under 70. January is a little under 50. January is a little under 50. So they use the same data. So you're looking for which one is true. This says they use different data. That's not true. They use the same. The scale on the horizontal, that means left and right. So here and here. On the second graph is misleading. Okay, the horizontal on the second graph, they are evenly spaced. That's not misleading. Okay, and they want the true statement. So no, this isn't true. The scales on the 2 graphs are exactly the same. No, if you look, these are evenly spaced. This distance on this one, this is for 1 bigger than over here for 10. And they also do a bit, this line here means they skip a bunch. So they just start this at a bigger data so they can stretch it out more. It makes it look like the data is, there's more differences between the months than there are here. So that's not true. So the answer here would be none of these. There's no true statement there. Okay. Let's look at number 2. Both graphs represent average number of rentals each day at sunny day videos. Which statement is true? So again, if you look, the difference here is, even though they're writing every 200, they go up by 100. So that's 100 there, 200, 300, 400, 500, and so on. Here, this distance, they're going up by 50s. And this distance from here to here is 100. But that same distance here, that would not put this at 0. Here, this would be, these are going down 100. So this would put that at 100 and this at 0. This would put this at 450, and this would be 400. So it's a little misleading. Okay, it's not starting at 0. The points are all the same. Like this is at 500, this is at 500. Okay, so let's look. It says which statement is true. The first graph does not exaggerate the changes in each year. Okay, so the first graph, they start at 0. It's evenly spaced all the way up. They don't exaggerate it. I think this is the right answer. I think that is true. Because over here, they do exaggerate. It makes it look like there's bigger jumps than there actually is. The 2 graphs use different data. That's not true. Like we just said, 1991 is 500, 500. 92 is 700, 700. So if you went through that, you'd see these are the same data. So that's not right. The scale on the second graph gives a more accurate picture. No, because they skip and they don't label this. So, and it makes it look like there's bigger jumps. So that's not true. So A would be your answer. Okay. One more of these, and then we'll do the box whisker plot. So let's go to number 5. And number 5, same type of problem here. It says which statement is true. So again, these go up by 1s, but they skip a bunch of data. They don't start until like at 50. Here, they go up by 10s, but it's up evenly. Okay, so let's look at the choices. Because of the scale in the first graph does not begin at 0, it distorts the relative heights of the bar, meaning it looks like 7th grade is over twice as much as 6th grade. But this is 51, that's 57, that's nowhere near twice as much. If you look over here, it tells the story a little more clear. They're actually pretty close. Okay, so because this is actually true, because of the scale of the first graph does not begin at 0, it distorts the relative heights of the bar. Relative heights mean comparative to each other. So it's not over twice as much or 3 times as much. Okay, and again, if you looked at these other ones, the second graph, it does not distort, so that's not true. The 2 graphs use different data. No, 6th grade's 51. This is just over 50, so let's look at 51, just under 60, so that could be 57, and so on. And the scales on the 2 graphs are the same. No, this goes up by, starts at 50 basically, and goes up by 1. This goes up by 10s. Okay, so that's some misleading graphs. Okay, all right, if this is getting a little long, press pause, come back. We got one type of problem left to do. And we're going to go all the way to the last page of this section. Go to 24. On 24. Right here, I'm actually going to take a little drink quick. So while we're talking here. All right, box and whisker plot. So what a box and whisker plot is used for is to show you how data is spread out. Okay, so we have the numbers here and it shows you, I'll talk a little bit more about this in a second, but it shows you the range and different items of your data within a graph. Okay, so first of all, we have to figure out which one of these, and you don't know what you might not know what a box and whisker plot is yet, but we're gonna learn it kind of by setting one up. So the first thing you gotta do is put the numbers in order. Okay, and I'll kind of skip ahead, but you would have to look through and say, okay, 25 is the smallest, so I'm gonna write 25. And then you just keep going, and you have to be really careful on this. Here's a 28. So I'm not gonna do step by step here because I've done this already, so I'll write them out to save some time. But you have to be very careful. And so there's 3 28s, there's 2 31s. Again, make sure when you're actually doing this, you take your time. There's a 34, 35, 36, 38. There's 3 39s. And a 42. Okay. So one way to this won't help you for sure, but to kind of help know if you got them all, count, say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And I think I might have missed one because if I count over here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So I missed something here. I got 2 31s, 34, 35, 36, 38. Okay, so missed something at the beginning. I missed the 32. Okay, so I think I can get that in there. So that's why you gotta be careful when setting these up. To 34. Okay, so now there's 15 here, there's 15 over here. So even though I had already pre-done this, I'm screwed up. So you really got to be careful when putting these in order. So to make a box and whiskers plot, there's 5 points you got to find. Okay, you got to find your minimum data point. You got to find what's called the first quartile. You got to find median, which we talked about in the first section of notes that we did for this session. You got to find what's called the third quartile. If you're asking where's the second quartile, that would be the same as your median. And then you got to find your maximum. Okay, so on these graphs, these spots would be the dots. So the minimum would be the first dot, first quartile, median, second quartile, maximum. And we just got to figure out the numbers here so we can figure out which graph is right. So the minimum is just your smallest. And your maximum is just your biggest. Okay. Next is to find the median. Okay, so the median, now when we counted these before, there was 15 pieces of data. So our median would have 7 before it and 7 after it. So 1, 2, 3, 4, 5, 6, 7. Okay, so it's probably right here, but let's make sure 1, 2, 3, 4, 5, 6, 7. So this is our median. Just 34. Now, to find your first and third quartile, you are finding the median of the first and second half. So if you have a median right in the middle, you don't count that as part of either half. So that's the first half of data. This is the second half of data. So in here, 1, 2, 3, 4, 5, 6, there's 7 numbers. So if we go 1, 2, 3 that way, 1, 2, 3. This, I'll use maybe a triangle this time. That's the median of the first half, so that's our first quartile. 1, 2, 3, 1, 2, 3. It's 39. It's our second quartile. So now what we got to find is minimums 25. So that works. That works. This is at 24. This is out 25. So we're all good. First quartile 28. So here's 30, 29, 28. Good. 29, 28. Good. 29, 28. Okay, so they're all still in it. Median 34. Here's 35. Here's 34. Ooh, that's one over. Looks like that's out. 34, 34. Good. Third quartile 39. This is at 40. This is 1 over 39. So this is at 40. That's out. So our answer should be here. Just make sure the max is 42, 42. So that's our answer. Okay. A couple other things that I'm going to just show you as far as notes here on what a box and whisker plot can do. Again, it shows the spread of data. What that means, besides just seeing where these numbers are, if I made just some generic box and whisker plot here, there's 4 parts here. Each part shows a fourth of your data. So even though or approximately a fourth of your data. So even though this looks way bigger than this or this, the amount of numbers in here would be the same. So like, and it's not always exact, like here there's 15. So approximately 15 divided by 4 is almost 4. So roughly in each section, there's going to be 3 or 4 numbers, or they might share a point. So the lines and the boxes just show how spread out those numbers are. So here, the little number, this does not go with this problem. This is just an example of notes. The numbers here would be way more spread out than the numbers here. Okay. Last thing I'm going to show you on this, just general notes. If you had an even number of data, so this is again just a different example. I'm just going to already put them in order. So just in case you come across, so up here that was an odd number of data, and it was easy to find the medians. So I just made this one really easy, up by 2s. If we had to find the minimum, the first quartile, the median, third quartile, and the max for this, well, again, 2 would be the median, or the minimum, 16 would be the max. The median, now there's 1, 2, 3, 4, 5, 6, 7, 8. So there's not an actual middle number. So 4 this way, 4 this way, these are your 2 middle. So you'd actually have, remember, you have to find the median with 2 in the middle. You add them up, divide by 2. Our median would be 9. So this is our minimum or maximum. This is our median. Now, there's no actual median that shows here, so we count from that point over as the first half. From this point over as the second half. There's 4 numbers here, 4 numbers here. So again, there's no median, exact median. So you would take 4 and the 6. You'd have to add them up, divide by 2. First quartile would be a 5. Same thing here. There's 4 numbers. If there was 5 and 5, then you could find the median of the half. So you add this, 12, and 14. That's 26 divided by 2, and that equals 13. So I just wanted to show you that if you had to produce one of those. The rest of the problems aren't that hard for the box and whisker plot. So these next ones will go pretty quick. So if we work backwards here, let's go to 21. Oh, actually, no, 23 first. So there's no actual math to do here. You just have to understand. It says they drew a box and whisker plot to represent for students' data or student scores on a midterm test. It says Barbara earned 85 on the test. Describe how the scores of Barbara's classmates compared to Barbara's scores. So Barbara scored an 85. Now remember, each one of these parts is a fourth, or if you want to call it percents, it would be 25%, 25%, 25%. Okay, so we need to look at, if she's here, there's one part that's above, there's 1, 2, 3 parts that are below. So here we want to find what's true. It says about 3/4 scored higher. No, only one part is higher. So that's out. Here, about 3/4 scored higher and half lower. No, again, only one part is higher, 1/4. Okay, so here, about 1/4 scored higher. Yep. About 3/4 scored lower. 1, 2, 3. That's 3/4. This should be the right answer. Again, let's check here. About half scored higher. Half would be 2 parts. No, that would be true for 66. And half lower. Again, that would be true for 66. Okay. All right. Almost done. Let's go back to 21. Find the range and interquartile range for the box and whisker plot. These should be easy problems. When you get a test on these should be easy. Range, just high minus low. So the high, we go down here, this is 41, 42, 43. Minus the low, go down to here. Well, it's 17, 18, 19. Subtract those. So the range is 24. So this one's possible, this one's possible. If we were confident we did that right, those two are out. The interquartile range is your third quartile. Let me erase that. A little more clear. Is your third quartile minus your first quartile. So third quartile is right here. First quartile is the one that's here. Okay, so here's 41. Here down's 21. Subtract those, you get 20. So here was the range. Here's the interquartile range, which just means the distance between the first and third quartile. So if we look, range of 24, interquartile range of 20. Okay, we might be almost done here. Number 15 is that same type of problem. We don't need to do that. 10 is similar to one of the other ones. I can give you a hint on 10, but we don't need to do it. So 10, just remember this type of problem. This is a fourth. This is a fourth. Even though they're different sizes, they're all about a fourth. One last problem, just to give you some understanding. Number 3, it's actually an easy problem, but you might not understand what it's asking. It says a box and whisker plot shows test score results. Which plot represents a situation in which all students scored similarly? Okay, so again, if they scored similarly, they're going to have scores close together. this, they're pretty spread out. They're from 40 to 100. That's not all similar. 55 to 95. Here, 60 to 80. Here, about 40 to about 95. So if they're all similar, it's the ones that are bunched closest together. So that would be letter C. Okay. So again, I got a little long, but nothing super hard, as long as you're following the steps that I put down there. I will go to the back page here and just circle the ones we did, so you know which ones we did, which ones you should have copied, and also which ones will help you figure out the other problems. So we did 6, 12, 13, 19, 8, 11, 3, we did all these. That's it. So again, the reason I circle these is because let's say you were trying to do number 7. Well, that's a circle graph problem. You should look at one of these other ones that I circled in the circle graph section. If you're doing number 10 and you can't find the answer, you should look at one of these other ones I circled in the box and whisker plot section. Okay? So again, get those notes copied, send me a picture of it to get the points for that. Then you should try some of the other problems. If you have any questions on either other problems you're trying or even the ones I did and you copied down and you need clarification, just ask and let me know. Okay, let's get these done. Make sure you get those points.